Hello and welcome to helpyourmath.com. In this video, we're going to look at writing equations of functions, specifically quadratic functions. We're going to look at some examples of writing the functions themselves given the graph, and then we're going to graph the function given the equation. So to get started, there's two ways that we generally present quadratic equations. We have standard form, and standard form for a quadratic is of the form f of x, or whatever the function name is, or we can say y, equals ax squared plus bx plus c. And then there's vertex form. And vertex form would be f of x equals a times x minus h squared plus k. And in vertex form, we're given the coordinates of the vertex are h comma k. And then a, actually in both standard form and vertex form, a tells us two things about the graph. It tells us whether it's opening up or down, and it tells us if there's a stretch or a shrink. We'll come back to that. We're going to worry about that in a minute. Let's see what we're dealing with. Write the equation of the graph shown in vertex form. So we want to use vertex form, which is the second one here. And if we're going to do that, we need to identify the vertex. And I see the vertex. It's the minimum of this graph. It's the bottom of the graph. And then I know something else about the graph. Because the graph is opening up, the parabola is opening up, I know that a must be positive. Okay, so the vertex is located at 1, negative 4. So we have one piece of information we need for vertex form, but the other piece of information we need is we need to figure out the value of a. And if you're super good at this, then you might know how to find a, and if you're not, that's fine. What we'll do is we'll find another point on the graph besides the vertex, and if you know me, you know that I like using anything that has a 0 in it, so I'm going to go all the way up here, and I want to use this 3, 0. There were two other 0 options, and there's a few other points you could use. You could have used this point right here, this point here, this point up here. Any of those would be just fine. And what we're going to do is we're going to plug in 1, negative 2 for h and k. 1, negative 4 for h and k, and we're going to plug in 3, 0 for x and f of x. And that's going to help us determine the value of a. So we're going to say 0 equals a times x is 3 minus h squared plus negative 4, which we could say minus 4, but I already wrote the plus, so we're going with plus negative 4. Then inside the parentheses, 3 minus 1 is 2, and 2 squared is 4, so I'm going to say 4a minus 4. Now we want to get a by itself, so I'm going to add 4 to both sides, giving me 4 equals 4a. Divide both sides by 4, and we determine that a is equal to 1. So when we write this in vertex form, we go back to f of x equals, we don't need to put the 1 because it's the identity, the multiplicative identity, and we can just say x minus 1 squared minus 4, and that would be the equation of this parabola, of this quadratic in vertex form. And our second example, whoa, we have a big stretch going on. Again, I see the vertex down here. So vertex form would be g of x, or f of x, or whatever you want to call it, equals a times x minus h, quantity squared, plus k. I'm going to make that minus sign look a little better. X minus. Okay, and we can see the vertex. We know that the vertex, hk, is located at negative 3, negative 1. And then we need to, I know that there's a stretch. I know a is positive and I know there's a stretch, but I'm not sure what the stretch is. So we're going to find another point on the graph, a nice point that goes through. I don't see any zeros, unfortunately, but I do see this right here. And this point is negative 1, 9. So I'm going to plug in negative 1 for x and 9 for g of x. And we're going to use negative 3 for h and negative 1 for k, and we're going to figure out that value of a. So we have 9 equals, I know it looks like an a, but it's a 9. 9 equals our unknown times x minus 1 minus negative 3 will become plus 3 squared minus 1. So then we get 9 equals, that's negative 1 plus 3 is 2. 2 squared is 4, so that's 4a. I can simultaneously add 1 to both sides. Whoops, I already wrote 9. You can change that. 9 plus 1 is 10. We're going to divide both sides by 4. 4's cancel there. And while 4 doesn't go evenly into 10, we do know that 4 and 10 are both divisible by 2. So I could rewrite this as 5 over 2. And you can leave it as an improper fraction. You can convert it to a mixed number. You can convert it to a decimal. I'm going to leave it as an improper fraction because the less work I do, the better off I am. And now we can write the equation in vertex form. G of x is equal to 5 over 2. It is positive, as it should be, times x plus 3 quantity squared minus 1. And that's the equation of this parabola. Our last parabola, I see the vertex is a maximum this time. This indicates to me that a will be negative because the parabola is opening down. And we want to find some other point on the graph. It looks like I have a 0 here. Yay! We have 3, 0. And we have our vertex at 5, 2. And we'll call this one h because we can. So this is going to be h of x is equal to a times x minus h squared plus k. We know that 5, 2 is my hk, that's the vertex. 3, 0 is just some other point, so we can call that x. And h of x, or again, you can use y if you want, that's fine. And now we're going to plug in 0 equals a times 3 minus 5 quantity squared plus 2. That 0 equals 3 minus 5 is negative 2. Negative 2 squared is 4. So that's 4a. Whoops, I did it again where I preemptively wrote the 0 when I wanted to take away 2. That's all right. So we have negative 2 equals 4a. Divide both sides by 4. And 4 doesn't go evenly into 2, but we can simplify. That would be negative 1/2. So now we know a, we know our vertex. We can write the equation in vertex form, except I just changed the name, which I can't do. Let's try that again. H of x is equal to negative 1/2 times x, what's my vertex? Minus 5 quantity squared plus 2. And there we have it. Okay, in our next example, this time we're given the equation in standard form. And the first thing we want to do is we want to switch it to vertex form. So if we're going to write it in vertex form, hopefully this isn't too much of a disaster. Let's see. What we're going to do is we're going to create some space here. And we want to turn x squared minus 6x into a perfect square trinomial. So we're missing the third piece. So I'm going to leave a gap there. I'm going to say plus 7 or minus 7 over there. So now, if x squared minus 6x is 2/3 of a perfect square trinomial, what would fill in the third third? Well, the way we can figure that out, we take the b, the term in front of x, or the factor in front of x, and we divide it in half. That would give me negative 3, and then we square it to give me plus 9. Now, if I add 9 to the right-hand side, and I can't just add 9 willy-nilly, the inverse of that would be to then take away 9. So I'm going to add 9 and subtract 9 from the right-hand side, because then the change that I've done is a net change of 0. But what that allows me to do is that allows me to write it in vertex form, because now I can say, hey, this is a perfect square trinomial. It's x minus 3, quantity squared. Minus 7 minus 9 is minus 16. That's going to go, oh, my graph almost fits it, but not quite. That's okay. Okay, so step 1 is done, or step A anyway. Step A is done. Step B, find the x-intercepts of the graph. So to find the x-intercepts, that means that we want to plug in 0 for y, or whatever y equivalent is, in this case f of x. So we're going to say 0 equals x squared minus 6x minus 7. I want to see if this is factorable, because if it is, that makes my life a whole lot easier. It is. This would be x minus 7 times x plus 1. That's good news. Then we set each factor equal to 0. That's x minus 7 equals 0. X plus 1 equals 0. Solving for x, we get x equals 7. And here we get x equals negative 1. Excuse me. So if we go back, so our x-intercepts, we have 7, 0 and negative 1, 0. Finding the y-intercept of the graph. So to find the y-intercept, that means we're going to plug in 0 for x. I find it's generally nicer to use standard form for that, because what's going to happen is this will turn to 0, this will turn to 0, and we're just left with negative 7. So the y-intercept would be 0, negative 7. And now we want to sketch a graph. Unfortunately, my graph doesn't quite make it. It's going to be just at the very, very bottom. You'll have to bear with me. What I haven't done yet is I haven't actually labeled the vertex. So let's just do that from part A. The vertex of this graph is going to be found at 3, negative 16. So I'm going to graph that point as best I can, going as far down. Oh, I think I went too low. All right, good enough. There's a point down there. We're going to call that the vertex. We're going to graph our other 3 points. 7, 0 is over here. Negative 1, 0 is here. We also have 0, negative 7 right here. Oh, it disappeared. That's sad. Let's put it back. Come on. Okay, hopefully it stays this time. And then I can use symmetry, because it's good to have more than, it's good to have 2 points on the left and 2 points on the right. I know that 0 is 3 units away from 3, so I also know that 6 will have y of -7 as well. So I'm going to put that right there. Okay. And then, oh, my point disappeared again. That's so sad. Why does that keep happening? And then we're going to graph our parabola as best we can on my little skinny graph. There it is. There's the graph of f. I'm going to call it f. Yay! Oh, and it already took me to the next graph. Okay. Next graph, we have g of x is equal to 2x squared minus 4x minus 5. And we want to write this equation in vertex form. Okay, so this one's going to be a little bit tricky because if we're going to complete the square, the x squared term needs to have a coefficient of 1, not 2. So what we need to do is we need to factor out the 2 from the first two terms. That's going to leave me with x squared minus 2x, and I'm going to leave a gap there. You'll see why in a minute, minus 5. So see, if I was to distribute that 2, I would go back to standard form, but we need to get this in vertex form, so that's why I did that. So inside the parentheses should be 2/3 of a perfect square trinomial, x squared minus 2x. The third third would be when we take b, divide it in half, that would be -1, and square it, +1. So it looks like I added 1 to the right-hand side, but actually I didn't. I actually added 2, because if we were to distribute the 2 back out, it would be 2 times 1. So I really added a 2 to the right-hand side. To undo adding a 2, I would need to then take away a 2. Now I have my perfect square trinomial. So we're going to write it 2 times x minus 1 quantity squared, then minus 7. And that's it for part A. That is the vertex form. Done. That was nice. Okay, now part B, we want to find the x-intercepts. Now, unfortunately, plugging in 0 for g of x, so this is where we plug in 0 for g of x, 2x squared minus 4x minus 5 is not factorable. So we're going to have to use either completing the square or quadratic formula. I much prefer quadratic formula, and since this is the video I'm creating, that's what we're going to do, haha. So for quadratic formula, it's already set equal to 0. We can label A as 2, B is -4, and C is -5. And we can plug in, that would be x is equal to inverse of -4, 4, plus or minus the square root of -4 squared is 16, minus 4 times 2 times -5, all divided by 2 times 2. Cleaning up that under the radical, the discriminant, we have 2 negatives, so that's going to turn that second term positive. And 4 times 2 is 8, and 8 times 5 is 40. Divided by 4. 16 plus 40 is, that's going to be root 56. Just due to lack of space, I'm just going to go ahead and do this here. And then 56 has a perfect square factor of 4. So that's 4 times 13. And then the square root of 4 is 2. So that's going to simplify to 2 root 13. And then lastly, 4, 2, and 4 all have a common factor of 2. So that's going to give me, oh, I said 2 and then I wrote 2. That's going to give me 2 plus or minus the square root of 13 over 2. So now I can write my x-intercepts somewhere, although I'm running out of space, I'm going to put them down here. So B, we're going to say we have 4 minus 2 root 13. Sorry, not 4, 2. No, and not 2, that's 1. Let's use the simplified one. Here we go. 2 minus the square root of 13 over 2, comma 0. And the other x-intercept would be 2 plus the square root of 13 over 2, comma 0. Unfortunately, those are going to be really tough to graph, so we're probably not going to get to use those points for our graph. But it asked us to find the x-intercepts, and that's what we did. Letter C, finding the y-intercept. Oh, this one's going to be much nicer. Breath of fresh air here. I'm going to go back to my standard form. If I plug in 0 for x, this goes to 0, this goes to 0, and we're left with -5. So we get 0, -5 here. Much better. Now we want to sketch the graph. So I'm going to graph the vertex. The vertex is going to be found going back to part A at 1, -7. Hey, this one fits on my graph. 1, -7 is going to be right here. And then I can also graph the y-intercept 0, -5. And I can use the symmetry of the graph. So 0, our x-coordinate, is 1 unit away from 1, the x-coordinate of the vertex. What's 1 away from 1 the other direction? Well, that would be 2. So 2, -5 is another point on the graph. And then, and then I would suggest 2 more points. Luckily, we can just use the symmetry to know that -1 and +3 will give us the same output. So if I use -1, I don't know why that point keeps disappearing. That's so weird. and 3 will give us the same. So whichever one you want to use, maybe we use 3 because it's nicer. You can plug it into either the original function, the standard form, or you can use vertex form. That shouldn't matter either. I'll use the standard form because why not? So I'm going to use 3 here. I'm going to put my point back because I'm very sad that it left us. Okay, so g of 3, that's going to be 2 times 3 squared minus 4 times 3 minus 5. 3 squared is 9, and 9 times 2 is 18. 4 times 3 is 12. 18 minus 12 is 6, and 6 minus 5 is 1. So I know that g of 3 is equal to 1, which means g of negative 1 is also equal to 1. So we're going to go back. G of 3, so 3, 1 is up here. And negative 1, 1 would be right here. So this is a stretch. It looks like there's a stretch here, yep, because the a is 2. So it's much skinnier than the last graph. And that's how we graph it. Now, I didn't do a great job here. This should be a nice smooth curve. It looks like a point, but it should be a nice smooth curve. And that's quadratic.